problem, we are given the null and the alternative. They're telling us that the sample size is 25. They collected the sample, they have the mean and the standard deviation of the sample. They're asking us to complete the test, to determine first the test statistic. Are we after Z statistic or T statistic?
This one would be T.
Of course, because we're not talking about proportions. We're talking about mean. Okay, excellent. So let's enter it. Stats. This time we have to look for the t-test. T-test, which is number 2. And with statistics, so we have mu0, which is 60. That comes from the null hypothesis. X bar, which is 56.6. Standard deviation 13.9. Sample size 25. And it happens that, oh no, this is the next one. No. Wait. Why is it jumping like that? Yes, okay, that's what I wanted. This is a left tail test. And I want to draw. Is everything okay? Yes, less than that. Yes, good. Huge p-value. So the test statistic is -1.223 and the p-value is 0.1166. No matter what alpha. They're giving us 0.05. So alpha 0.05. So now we have to make a decision. What is the decision here? Anyone?
Fail to reject.
Yes. Fail to reject, which means that there is insufficient evidence. There is insufficient evidence to conclude mu less than 60. If we reject, we will say there is sufficient evidence to conclude. But if we fail to reject, we say there is insufficient evidence. Good. Okay, moving on. I wanted to look at some okay, let's also construct a 99% confidence interval. Now, a question here. I'm just going to add a question on this problem. Let's say since we have alpha 0.05, so if this is 0.05, then we are looking at a 90% confidence interval because we have to have the other tail. So this will be 5%, 5%, so the confidence interval is 90%. Will this confidence interval it's better to discuss this question actually for 2 populations, either means or proportions. Okay, I'll come back to this. That's a better situation that I would like to come back to. It's better to use this, the question that I was going to ask for 2 populations, either means or proportions. Because that's when we discussed that. I was going to ask if it contains 0, but this is relevant for 2 populations. So to compare these 2 results. So normally, what my idea was that when we fail to reject a null hypothesis, normally it's the interval contains 0. That's why we failed to reject. But when we talk about two populations, right? So if this is negative to positive, then we cannot conclude which is bigger. But if it's entirely positive, then mu1 is bigger. If it's entirely negative, then mu2 is bigger, or p2 is bigger. But this is more relevant for two populations. So I'm going to get to an example with two populations. I selected some here at the end. So, but let's create this 99% confidence interval. So this is problem 29. Let me go to the next page. So let's take a look. And this is 29 from the review. Several years ago, the reported mean age of an inmate on death row was 41.5 years. A sociologist wondered where the mean age of a death row inmate has changed. So if we had to conduct a test of hypothesis, has changed, will mean mu1 is the same. I mean, just mu, we only have one population here. So mu equals 41, and this is also mu0, 41.5, and the null hypothesis will be that mu does not equal 41.5. It doesn't say, it says has changed. It doesn't say has increased or decreased. Increased, decreased, but it says has changed since then. So if we had to conduct a test of hypothesis, we would have to write that first. Okay, she randomly selects 34. Right away, I know that n equals 34, and finds that their mean age for these 34 is 43.3, with a standard deviation of 8.3. Construct a 99% confidence interval about the mean age of the death row inmates. What does the interval imply? So that's one of the questions. Good, so we have all the information. So we go to stats, tests, and we want to create a t interval. This is a t interval with statistics. X bar, 43.3. Standard deviation, 8.3. Sample size, 34. And 99%, and calculate. So it's 39.409, comma, 47.191. Okay. That's exactly pretty much what I wanted to ask for two populations, but the problem we chose is just perfect for that. So see what happens here. So this is the 99% confidence interval. 41.5 is somewhere in the interval, like the 0 from mu1 minus mu2. Same idea. So 39.409 and 47, you see 41.5 is somewhere between these two numbers. We cannot conclude that mu has changed. What if I had obtained this interval, 23.4 to 32.1? Or what if I obtained this interval 45 to 50.2? I would have guaranteed from this sample, not guaranteed, but just from this sample, I would have said, yes, because 41.5 is not here and 41.5 is not here. If I get this or this, I'll say, yeah. The sample suggests that that is no longer true. But because 41.5 is in the interval, I cannot conclude that the mean has changed. The mean number of years of these people on death row has changed from 41.5. So there is a correlation between test of hypothesis and the confidence interval. However, as I mentioned, they may conflict. I may decide here that to reject a null hypothesis, and this may not reflect the same conclusion. It is possible. Not unheard of. Okay, but in this case, I did not conduct the test. But in this case, because 41.5 is in the interval, in other words, it's not consistent, the interval is not consistently lower than 41.5 or consistently higher than 41.5, I cannot reject this. It didn't appear. If it's still here, it doesn't appear that it has changed. Okay, good. That was 29. Okay, if I ask you to complete the sentence, a sampling method is blah, blah, when the individuals selected for one sample are used to determine the individuals in the second sample.
Dependent.
Very good, awesome. Dependent. So if I use from a sample to the individuals to select the other one, in other words, I take your blood pressure before you exercise and after you exercise, that's dependent. The second sample is dependent on the first. I chose you on the first one. I have to choose you on the second one after you finish exercising. So that's dependent. A sampling method is independent when the individuals selected for one sample are not used to determine the individuals in the second. Great job. Thank you. Okay, so here's another example. 31. Let's take a look. A survey asked, how many tattoos do you currently have on your body? Of the 1,003 males surveyed, 188 responded that they had at least one. Okay. Of the 1,061 films, so now I know this is N1 and this is X1. And this will be P1 hat S188 over 1303. Of the, okay, then I know for sure that this is N2, 1061 female surveyed, X sub 2, 148, responded that they had at least one tattoo. Construct a 95% confidence interval. And of course, P2 hat would be 148 over 1061. 95% confidence interval to judge whether the proportion of males that have at least one tattoo differs significantly from the proportion of females that have at least one. So if we were to conduct a test statistic, I would have used P1 equals P2. As you know, the same thing, P1 minus P2 equals 0, same thing. And the alternative, differ, or P1 minus P2 not equal 0. Same thing. This is the same with this, and this is the same with that. So let's determine the 95%. So this is 2 proportions Z interval. 2 proportions Z interval. X1. Say it again.
I'm sorry. It was 1,203 males surveyed instead of 1303.
Oh, yes. Thank you. My nose is too long. I couldn't see around it. Just kidding. 1203. Okay, and then N1. 188. Be careful. 188 and N1 1203 and X2 148 and N2 1061 and we want 95. and we calculate. Aha! So the 95% confidence interval is negative 0.0125 and 0.04604. You understand that this is the difference between the difference of the two. Okay. So they're asking us now to conclude based on the confidence interval. What do you think? Do we reject? Are they different? Or we fail to reject?
No, it's reject.
Yes, because 0 is there. Excellent. Thank you. 0 is in the interval, meaning if the interval were consistently negative, then I'll say, yeah, of course. If the interval would be consistently positive, then I'll say, yes, of course. But since 0 is inside the interval, I cannot reject this. So fail to reject. H0.
I have a question.
Yes.
It may kind of be a stupid question, but anytime it's a negative and a positive, it's always going to be fail to reject.
Yes.
Okay.
Because, but remember, this conclusion may be different than this one. From determining the test of hypothesis, determining the test statistic, and the p-value. It can happen. But we did not conduct the test based solely on the 95% confidence interval. Because 0 is in the interval, I cannot conclude which one is higher. If the entire interval is negative, then I know P2 is higher. If the entire interval is positive, then I know P1 is higher. But now I'm lost because I have negative values and positive values. I don't know which one is higher, so I cannot reject this.
Okay, that makes sense. Thank you.
Thank you.